All right, what if I told you that a single, quick picture of your brain could tell you how fast your entire body is aging? I know, it sounds like something straight out of science fiction, but it's not. And the story of how scientists figured this out, well, it's pretty amazing.
So, here's the big question. How fast are you really aging? It sounds simple, right? But the answer is, well, it's complicated. You know how it is, we all know people who just seem to defy their age, and then others who seem, a bit older than their years. For decades, scientists have been trying to figure out how to actually measure this, and that really gets to the core of it. On one hand, you have your chronological age. That's just the number of candles on your cake. But on the other, you have your biological age, which is all about the real-world wear and tear on your body. And the huge challenge has always been, how do you reliably measure that?
Okay, so let's get into the first big piece of this, the aging puzzle. We're talking about why scientists desperately needed a better way to measure how we age.
And here's the problem in a nutshell. We all age at different rates. But how do you actually measure that accurately and reliably? I mean, think about it. If you don't have a good yardstick for biological age, you can't really test what might slow it down. You can't figure out why two people born in the exact same year can end up on completely different aging tracks.
So that brings us to Section 2, a 5-decade experiment. This is all about the truly remarkable study that made this whole breakthrough possible.
Now, the key to unlocking this puzzle wasn't some fancy new gadget. It was pure, old-fashioned dedication. It came from something called the DUNEDIN study. Get this. They enrolled over 1,000 babies born in New Zealand back in 1972 and 73. And then they did something incredible. They followed them for their entire lives. For almost 50 years, researchers tracked their health with just an insane level of detail. The sheer scale of this thing created the perfect set of data for understanding how we age.
And with all that incredible data, scientists were able to create something they called the pace of aging. Now, this isn't just a single snapshot in time. It's more like a speed. It calculates how much your body is actually declining for every birthday you have. It basically became the gold standard, the ultimate way to measure biological aging.
And when I say they tracked their health, I mean they tracked everything. We're not just talking about cholesterol here. No, they tracked 19 different biomarkers across pretty much every system in the body: cardiovascular, metabolic, immune, kidneys, lungs, even dental health. This gave them a genuine head-to-toe picture of how each person was actually aging.
All right, Section 3, a window into aging.
Because, that pace of aging score is amazing, but it took decades to collect the data. So the next big question was obvious. Could there be a shortcut? A way to get that same incredible insight from just one quick measurement?
And this is where things get really cool. This is the big breakthrough. The researchers took those pace of aging scores, the ones that took 20 years to figure out, and paired them with something else. At age 45, they gave everyone in the study a simple, quick, T1-weighted MRI brain scan. Then they asked the big question: could we train an AI to look at only the brain scan and figure out the person's long-term pace of aging? They fed all this data to the model, and it worked. It could do it. They called this new tool DUNEDINPACNI.
I mean, listen to how the researchers themselves put it. They called it a brain-based measure trained to directly estimate longitudinal aging of non-brain organ systems. That's a mouthful, but what it means is mind-blowing. They taught a computer to look at your brain to see how the rest of your body is aging. This was the first time anyone had drawn such a direct line between the physical state of the brain and the health of, well, everything else.
Okay, moving on to Section 4, what the scan reveals. Because, sure, they built this cool AI model, but the real test is, what can it actually do? What does it tell us? Does it even work when you try it on other people outside the original study? So can a single brain scan really predict your future health? Well, when they took this tool and tested it on thousands of other people in totally different studies, the answer was a huge, resounding yes. The predictive power of this thing was, frankly, startling.
So let's start with the brain itself. They found that in healthy people, a faster score on this brain scan meant a 1.49 times higher risk of developing mild cognitive impairment or even dementia later on. Think about that. The scan can spot the risk years, maybe even decades, before any symptoms actually show up. But here's the thing. As incredible as that is for predicting brain health, we have to remember what this tool was trained on. It wasn't just brain data, it was whole body health data. And this is where it gets truly groundbreaking. This isn't just a brain age scan, it's a body age scan read from the brain.
And they proved it. They looked at data from other huge studies like the UK Biobank, and the connection was crystal clear. It showed this perfect, direct relationship. The faster a person's brain was aging, according to the scan, the more physically frail their entire body was. It's right there in the data. A faster pace means a frailer body.
And it didn't stop there. The predictions just kept coming. A faster score also predicted more shrinkage in the hippocampus, the brain's memory center. It predicted a higher risk of being diagnosed with chronic diseases later in life, things like stroke or heart disease. And, most sobering of all, it even predicted a higher risk of earlier death from any cause. All of that just from one simple brain scan. Which brings us to our final section, a new tool for science. With all this insane predictive power, what does this actually mean? For research, for medicine, and maybe even for you? Well, first, let's see how it stacks up against the old way of doing things, something called the brain age gap. When you put them head to head, it's not even close. For predicting who would go on to develop dementia, for predicting disease risk, for predicting mortality risk, DUNEDINPACNI was a stronger predictor time and time again.
So, what makes DUNEDINPACNI such a complete game changer? Well, a few things. First, it was trained on people born in the same year, so you don't have weird biases from different generations. Second, it's built on 2 decades of real health data, not just one little snapshot. Third, it's catching the aging process before major diseases have a chance to develop. And maybe the most incredible part? The software can be run on thousands of MRI scans that already exist all over the world. We can just unlock this massive treasure trove of information that's been sitting there all along.
So, if you take away one thing, let it be this. We have gone from needing decades of super careful tracking to getting a profound insight into how your entire body is aging from a single painless brain scan that takes just a few minutes.
And that leaves us with one final massive question. If we can finally accurately measure the pace of aging, can we finally learn how to slow it down? For the first time, we have a tool that could let us effectively test all the things, the lifestyles, the medicines, the interventions that might help us all live not just longer but healthier. The race to find out is officially on.